Elements and compounds are different on the particulate level. A particulate level is looking at the individual particles. So we've seen a diagram like this before. With pure substances, they can be elements or compounds. Elements can be atoms or molecules. In compounds, it turns out there's two different kinds of compounds. We're going to talk more about each of these. In an atomic element, the individual particles of that element are just individual atoms, whereas a molecular element has molecules inside of it. Compounds can be either molecular molecules, where these guys are stuck together with chemical bonds, or they can be ionic, where we have a positive ion and a negative ion, and the attraction between the opposite charges is what holds that compound together. Most elements are atomic elements. There is a group of elements that are molecular. Diatomic. Di is a prefix meaning two atoms. So two atoms bonded together as the basic unit for that element. Here's a picture of some mercury. It's really a shame that mercury is toxic because it's really fun stuff. But mercury is an example of an atomic element. Mercury is very bizarre because it's a metal, but it's a liquid at room temperature. This is really neat stuff. But if we were able to zoom in and look at it, we would see that it is composed of individual mercury atoms. Whereas an element like chlorine is a gas at room temperature, and if we could zoom in, we would see that each of the particles is a molecule. These guys go around in pairs, kind of like junior high girls. Did you ever notice? Someone pointed this out when I was in junior high, that junior high girls never go to the bathroom by themselves. They always take a friend. It's the strangest thing. And they had pointed that out, and yet I couldn't help myself. This is very bizarre. Anyway, these elements are a little bit like junior high girls. They always have a friend with them. They're never alone. There are 7 of these elements, and we need to know which ones they are. Whenever we see one of these 7 elements, the formula for the element is the element symbol with a subscript 2 because it's a diatomic molecule. It's not a compound because it only has one kind of atom in it. It's an element, but it's molecular. Do I have that written out? Yeah, I do. There it is. So I've come up with 2 ways to help you remember this. The silly sentence, or the mnemonic, is what most people prefer. Horses need oats for clear brown eyes. So the first letter of each of these words is the element symbol. Okay, so eyes isn't exactly right, but it's good enough, right? Hydrogen, nitrogen, oxygen, fluorine, chlorine, I even got the Cl in there, bromine, Br, eyes, iodine. Okay, those are the 7 elements. So if you don't like that, there are 7 of them, and they start with number 7, and they make a 7 on the periodic table. Let's see. There's got to be a better way to do that. Oh, there it is. You see the 7? Starts at the number 7 and makes a 7, plus our little friend hydrogen. There has to be an exception to everything. Compounds can be molecular or ionic. A molecular compound is going to be formed from 2 or more nonmetals. Nonmetals form negative ions, anions, and so you're not going to be able to get 2 anions to combine with each other in an ionic way, but they will agree to share electrons and make molecules. Ionic compounds are going to have cations and anions, and usually, almost always, it's a metal and 1 or more nonmetals. Here are 2 different types of compounds. Here's dry ice, solid carbon dioxide. This is a molecular compound. Carbon and oxygen are both non-metals. Non-metals form molecules. Here we have sodium chloride. Sodium is a metal, chlorine is a nonmetal. One forms a cation, one forms an anion, and then they're attracted to each other. So the individual units that compose these little salt crystals are ions. There's one chlorine for every one sodium ion. And that's why the formula is sodium NaCl. There's one of each. It's a 1-to-1 ratio. There are not actually individual molecules in an ionic compound. It's just a big array. Sodium, chlorine, sodium, chlorine, sodium, chlorine in 3 dimensions. In a molecular compound, you do have individual molecules. They may all be shoved together, but they do have individual molecules. So the ionic compounds, again, a metal and a nonmetal. No, that's not what I wanted. I wanted this guy. So to identify it as an ionic compound, if there's a metal in it, done, ionic. And like I just mentioned, they don't form molecules, and so we call them formula units. A formula unit is just the smallest whole number ratio of the 2 different ions. Sometimes we kind of get sloppy and talk about molecules or something, but ionic compounds don't really have molecules. They have formula units. Okay, so let's look at these guys and classify them, each substance. Is it an atomic element, a molecular compound, or an ionic compound? Chlorine. First, let's identify, is it an element or a compound? It's an element. So most compounds, not all of them, but most compounds have 2 names. Just like most people have 2 names, right? My name is Jody Kawagoe. I go by 2 names. So when you see something that just has a single name, chances are good it's an element. There are some exceptions. Water is one of them. But this one is an element. So chlorine is on the periodic table. Is it atomic or molecular? Horses need oats for clear brown eyes. It's molecular. It's one of the 7. So it's a molecular element. How about NO? That looks like text shouting, no! It's a compound. We look at this and we see 2 capital letters. If it was an element, it could only have 1 capital letter. 2 capital letters tells us it's 2 elements. So this must be a compound. And then we're going to look what kind of elements are nitrogen and oxygen. They're both nonmetals. Is it going to be ionic then? No. It will be a molecular compound. For the purposes of this class, in order for it to be ionic, it has to have a metal in it. There are very few exceptions. How about Au? That's an atomic element. We recognize it as an element because it only has 1 capital letter. It's not one of the 7. So the 7, horses need oats for clear brown eyes, those guys are molecular elements, and we're going to consider all the rest of them to be atomic. There's a couple others, but we're going to ignore them. This reminds me, this is really bad. So it's one of those jokes that I can't remember exactly how it starts. Well, what do you say when someone snatches your gold necklace and runs off with it? Hey, you, come back here with that. Hey, you, gold. It's bad. Might help you remember it, though. Hey, you.
The one I heard was, like, if you were getting robbed, they would, like, point your gun at you and be like, hey, you, give me your gold.
Oh.
And when they get the bag, they open it up and they say, ah, gee, it's only silver.
That's better. I like that. I like that a lot. That's much better. Oh, gee. That's excellent. Thank you. I collect these things. Na2O. Element or compound? Compound. How do we know? Two capital letters. There's two element symbols there, Na and O. How do we identify whether it's ionic or molecular? If there's a metal, it's ionic. If there's no metal, we're going to say it's molecular. Is sodium a metal? Where is it on the periodic table? We don't think of sodium as being a metal because we think of it as part of table salt and, oh, I'm on a low sodium diet or whatever. We don't think of it as being a metal. But where is it on the periodic table? It's over there with the metals, right? Everything to the left of that stair-step line is going to be a metal. Now, what about those metalloids? In terms of naming compounds and thinking about compounds, the metalloids on the left of the line kind of get lumped in with the metals, and the metalloids on the right of the line get lumped in with the nonmetals. So because sodium is a metal, this is an ionic compound. How about CrCl3? It's a compound. And where is Cr in the periodic table? It's one of those transition metals. Metal means ionic compound. Metals form cations. Nonmetals form anions. Opposites attract. This can form an ionic compound. Something like NO, nitrogen wants to form a negative ion. Oxygen wants to form a negative ion. If it's ionic, they are not going to form a compound.